Learning week 7. I think it's Monday. All right. Present. Okay. So, this week we will be talking about symmetry. There's a really good video on vocabulary of symmetry, so you should go check that out. I would pause here before you do that. But no, I would pause here and then go do that and then come back and watch it. The rest of this video, because this video, the symmetry video, will help you understand what we're about to talk about. You will need this vocabulary chart. It's part 3. There's only 4 vocabulary terms for today. So if you haven't already, either print it out or replicate it so that you can take some notes. So symmetry is when an object looks the exact same on one side as the other. To see if an object is symmetrical, you draw a line of symmetry or a line dividing an object to show a perfect match on each side. And it's like making a mirror image. A line of symmetry is the actual line that divides the figure into 2 or more equal parts. Well, technically it's 2 parts, but you could have multiple lines of symmetry, if that makes sense. Like that says some shapes have multiple lines of symmetry. Like you can see a square has 4, rectangle only 2, an isosceles triangle only has 2. It just depends on the shape that you are looking at. So we're going to talk about vertical and horizontal. Vertical is something that rises straight up and down. I like to think vertical starts with a V. The sides of the V are like almost straight up and down. So that helps me remember that vertical is straight up and down. And horizontal is a line that runs from left to right. So I like to think of the H in the middle is a horizontal line. So that helps me there too. So finding symmetry. You can find symmetry by folding shapes in halves, fourths, sixths, etc. So together we're going to try finding lines of symmetry. So this document is linked in the grid. If you can, print it out. If you can't, replicate some of the shapes and cut them out. They're not going to be perfect because like if you're drawing them, they're not going to be like a perfect square or a perfect size like pentagon or whatever. But it'll still help you get the idea. So I have a video next that I'm going to play for you guys to help you see how to find lines of symmetry in paper shapes. So I'm going to hide my video here and play this one.
Hey guys, what's up?
Oh gosh.
Hey guys, what's up? Okay, so we are going to be practicing finding lines of symmetry. So, you guys had a paper that we just saw on the slide before this, with all these, and I cut these out. So, what I encourage you to do is print the sheets out if you can. If not, try your best to recreate the shapes, but just know that they're not going to be totally accurate or like the right sizes completely, but it's still good to be able to practice. So recreate some of these shapes if you can't print them out. Beep, beep, beep. Okay, so we'll start with this shape, which most of us may call a square. So we're going to practice finding lines of symmetry. So how you do that when you have an actual like piece of paper and not just like things on a screen, you fold it. You start by folding it in half. And you see, are these sides symmetrical? Yes, they are. They are the same. This right here is the line of symmetry. The cool thing about a square and some other shapes is that you can fold it a lot of different ways and it'll have a lot of different lines of symmetry. So this is one line. I can have a second line. See? So it has that line of symmetry. Here, I might even draw on it to represent it. It's not going to be perfect. So we had our first line of symmetry, right, from when we went like this. And then we had our second line of symmetry, and I'm just going right over that folded part. Okay, so far we have 2 lines of symmetry. But guess what? There's one more, at least one more. I'm going to fold this like a pizza. Like a piece of pizza, or like a handkerchief. Let's see. When we fold it like this, are each of the sides the same? They are. And the cool thing about a square is that it has another line of symmetry. Okay. So, this square has 4 lines of symmetry. Okay? All of those little pieces are symmetrical also. And like this side, symmetrical to this side, symmetrical to this side, yada, yada, yada. Okay, then we have a heart. And let's fold the heart in half. Do it with me if you can. You can see the line of symmetry. Both sides are the same. Draw a line. Let's see if we can do another line of symmetry and maybe fold it the other way. Although, what do you notice when you try and fold it the other way? They don't match up nicely. They don't fold nicely on top of each other. Like when you fold it like that, the bottom is not symmetrical to the top at all. So actually a heart only has 1 line of symmetry. Okay? Let's look at this triangle. And I'm going to fold it in half. Like this. It's a little triangle. Those sides are symmetrical, right? So we know it has at least 1 line of symmetry. But then look, what if we, so this is the bottom now, what if we make this the bottom? Let's see if it's symmetrical again. Ooh, this, my friends, is not an equivalent triangle. See how it doesn't fold up or match nicely? So that does not have, that's not a line of symmetry. Let's try this bottom one. I got lucky the first time I did. Oh yeah, doesn't line up. So this must be an isosceles. Is that what it's called? Yeah, it's when the 2 sides are the same length and the bottom is 1 length. So it has 1 line of symmetry. Let's do this little doohickey here. We know we can fold it in half like this. Right? Those sides are equivalent, so it has at least 1 line of symmetry. But then, what if I try to fold it like this? Does it have more than 1 line of symmetry? Nope, because that part is not symmetrical to that part. So this only has 1 line of symmetry. Let's look at this. Do you think this is going to have any lines of symmetry? It's not. Spoiler alert. Because look, when I go to fold it in half, it like has this whole part that does not match up. Also, if you fold it like this, looks like you're about to make a paper airplane, but it does not match up. So this does not have any lines of symmetry. This trapezoid. So I'm putting that in a different pile. What about this trapezoid? I'm not sure exactly. I think it might be called like an equilateral trapezoid, or I'm not really sure. Don't hold me to that. But let's see. We can fold it in half like this, and it's equal, symmetrical on both sides, right? But what about if I fold it in half, like hot dog ways? Is that symmetrical? No, because it doesn't completely fold over perfectly, so that just has one line of symmetry. So far, everything except our squares had one line of symmetry. What about our circle? Oh, let's fold it in half. Symmetrical on both sides? Yep, so I'm going to draw my line of symmetry. If I fold it in half again. Symmetrical on both sides? Yep. What if I fold it in half again? Is it symmetrical every time? So far. What about this way? I'm folding it in half different times every single time, or different ways every single time. And it's still symmetrical every single time. Something interesting to know about the circle is that it has an infinite amount of lines of symmetry. Like, you could keep folding this circle in half an infinite amount of times to get infinite amounts of lines of symmetry. It's just like all over. There's lines of symmetry, the whole entire thing. So that's cool about circles. Okay, so this, my friends, is a hexagon. It has 6 sides. You can fold it in half like this, and then it looks like a trapezoid. Right? There's a line of symmetry there. Wow, this video is already 8 minutes long. Sorry, friends. You could fold it this way to be symmetrical, right? You could fold it this way. The good thing about putting the lines of symmetry is you can easily remember what you've already done. Okay. You can fold it, let's see. Oh yeah, we haven't done this way yet. You can fold it like the other way, make a trapezoid. Good. And you should be doing this with me. You can fold it another way to be a trapezoid, but each way, it's a different line of symmetry, right? You can see that because we haven't put our pen on it, or we haven't, like, drawn the line, obviously. You can do it this way. I think this might be the last way. Yeah, I think that's it. So that one has 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6 lines of symmetry. Right? 1, 2, 3, 4, 5, 6. Yep, that's pretty cool. Rectangle. It's going to be very similar to the square. It's going to have this line of symmetry right here when we fold it. And I said it was going to be similar to the square. I didn't say it was going to be exactly like the square. Because, you'll see in a second. You have that line of symmetry. And something interesting that you might not know is that it does not have the diagonal line of symmetry. See? When you try and fold it like that, it doesn't match up right. Right? So it does not have either of the diagonals. The line of symmetry. So this only has 4. I mean, sorry, 2. lines of symmetry. And our last shape is the pentagon. Has 5 sides. So we're going to fold it like this. Oh yeah, I should probably show you. See, like that, and it has a line of symmetry. But see, we can't fold it like this, right? But we can act as if the bottom changes. So like if that's the bottom, you fold it like that. This is the bottom, you fold it like this. And it's always symmetrical that way when you do it with this shape. And then if we change the bottom to be that. See? And I think there's one more. Or 2 more. Now we make that the bottom. Remember, you should be doing this with me too. It shouldn't be boring because you should be doing it with me. I know it's long, but just quickly. And lastly, we make this the bottom. And that should be our last line of symmetry, which makes us have 1, 2, 3, 4, 5 lines of symmetry. Oh, that's interesting. The hexagon has 5 sides and has 5 lines of symmetry. I meant to call this a pentagon. Pentagon! The hexagon has 6 sides and 6 lines of symmetry. So that's interesting. I forgot about that part. Yeah, so glad that you did that with me, and we'll move on to the next slide.
All right, guys. So, let me turn my camera back on. Okay, so we're going to practice finding or not finding lines of symmetry in these 4 shapes. Rectangle, square. Oh, now I forgot what that was called. Oh, I shouldn't have started by naming them. Now I have to finish naming them. Rhombus. This is embarrassing. A parallelogram with opposite equal acute angles, opposite equal obtuse angles, and 4 equal sides. No, that's not a rhombus. Okay, hold on. Shapes. And this is lame-o. I think it might just be a parallelogram, the blue one. Okay. All right, and then that yellow shape is, I don't think it has a name. Well, it's a quadrilateral because it has 4 sides. Alrighty, so think in your head, where would a line of symmetry be on this rectangle? There would be one right down the middle. Boop. And there's another one. You tell me where it is. Tell me. I can't hear you. Right there, the other way. There would not be a diagonal one because, like we talked about before, it would not match up when you fold it. How many lines of symmetry does this shape have? Tell me the answer. Yell it out. It's 2. Okay. Now we have this shape, which is a square turned sideways. I don't really know if that has an actual name. It's just a square turned sideways. Okay, let's see. Where's the first line of symmetry? Right down the middle. Good. We have another one there. Can you think of another one? Tell me. Yoo-hoo, tell me. There. And there. I don't think I missed any. I think it has 4. Yeah. Okay. Let's look at this shape. Is that a line of symmetry? What do you think? Yes or no? What do you think? Why is it not a line of symmetry? What makes it not symmetrical? What about this line? Is this a line of symmetry? Why not? Because it wouldn't be symmetrical on both sides. And that's what symmetry is. And we've got our parallelogram. Is there any lines of symmetry on this shape? Is that symmetrical? Yes or no? Why isn't it? Because if you fold it like that, it would not be symmetrical. It would not match up perfectly. And what about this one? What about this? Is that a line of symmetry? No, because if you folded it, it would not fold nicely. Okay, so now I want you to try finding lines of symmetry on shapes that you create. Pause the video and take a few minutes to draw 3 shapes and find their lines of symmetry. So try shapes that we haven't used yet. I know we've used a lot, but just see if you can find lines of symmetry on your shapes. Make sure you're actually drawing real shapes and not just like squiggles. They have to be shapes. But I'm interested to see what kinds of lines of symmetry you find. And when you're done with that, you should have paused it and done that and then come back. You're doing this puzzling pentagons. And this is linked in the grid. Mrs. Sutton challenged her class to find a line of symmetry on a regular pentagon. Below is a table showing the results from some of her students. Which students correctly drew a line of symmetry? So this will be good because we just worked with the pentagon. So you can even get your pentagon back out and check and see. Then it says, choose one student who did not draw a line of symmetry in the correct place. Explain why that student's line does not show the symmetry in the pentagon. Oh, look, it gives you your very own regular pentagon. Draw all the possible lines of symmetry. Well, you already probably did that. If you didn't, do it here. And then it'll ask how many lines of symmetry does it have. And yep, that's it. Have fun. Can't wait to see what you guys come up with, and let me know if you have any questions. Bye!